So you started with inverse
Very
kinematics.
good. Yes, we started with inverse kinematics. Did I give you the basics of inverse kinematics? I think yes, right?
Yes, sir.
Yeah. So is forward kinematics important for inverse kinematics? Forward kinematic model?
Yes, sir, it
Yes,
is.
yes, it is, right? So what does it really mean is, please understand here, what does it really mean here is, I really want this 4 cross 4 matrix. Unless I have this 4 cross 4 matrix, I'll not be able to really compute this joint angles. And what does this 4 cross 4 matrix gives? It is nothing but your forward kinematic model, right? So forward kinematic model is very important to compute basically the inverse kinematics or my joint angles, right? All right. Now, so this and all I explained, right? So I think I explained very well all these things. So I'm not wasting my time again. So what are the typical problem for solving nonlinear inverse kinematics? One is the existence of solution, right? So what are the issues? First issue, I'll call it as existence of solution. When does this happen? Why is it existence of solution itself is a trouble? That means you do not know whether a solution exists or not. When does it really happen?
So when the pose is like given outside the work volume.
Yes. So that means when you have a point or the pose which is outside your work volume, right? So which is not where your end effector can really reach, right? So if you assign certain Cartesian points or a pose which is outside a work volume, of course you'll end up in null solutions, right? Which is a complex solutions which you cannot even get, which your end effector cannot reach. And second is basically which I already said, multiplicity of solutions. What is that multiplicity of solutions? What do you mean by that? Multiple solutions? Multiple solutions simply means for a same pose which my end effector is giving, there might be multiple ways to reach there, right? Which I already gave an idea. So this is again one. So how do you choose it? I gave even an idea like how do we choose it? There are no exact rule like how do we choose, but how do we really, to some extent, like what is an idea? How do we really choose it? I hope I gave you an idea with this.
The environment.
Yes, very good. One is the environment. Very good. So if environment is not a bottleneck for you, what is the other way to do that? I'll just minimize the amount of joint actuation, right? Which can, for example, the same here, if you could see an obstacle is there, if my obstacle would have not been there, how will I move from A to B? I would have taken this path, right? Why? Because it is leading to a very minimal joint actuation, right?
Yes, sir.
Yes. So this is how we really define. So either of the way, right? And there is no hard and fast rule like which one you should use. It's all about like which one you prefer to do. Okay, right. Right. So what are we going to do now is just to understand like how do we solve for inverse kinematic problem. There are ways to do that. I'll tell you. But if you go deep into this inverse kinematic problem, we understand what we have here is basically a 4 cross 4 matrix which contains basically total 16 elements, and you understand these 4 elements have no much significance, but you have total 12, right? So that means you end up in 12 equations. Does it make sense? Think of when you
Yes.
relate it with something, you end up in 12 equations. Now, when it comes to 6 degrees of freedom, how many unknowns will be there? Unknowns, what I say is a joint variables. How many? For a 6 degrees of freedom, how many joint variables? 6
Six
joint
unknown.
variables, right? So that means to the max 12 equations, I can have 6 unknowns. So what is the point here? I need to bring it down so that I can have only 6 equations and 6 unknowns which could be solved. Are you able to understand? And these are
Yes.
nonlinear equations. These are very highly nonlinear equations. So it's not easy to really solve it very directly. But we'll see like how do we really do it by, we normally say like we could also do it by just direct inspection. Okay, we'll see like how we do this direct inspection and try to solve for. Okay. So this is a general this. Now think of if it's not a 6 degrees of freedom. For example, I say it's a 4 degrees of freedom. What is the point here? How many equations? I have 12 equations, right? Then how many unknowns I have? Is it 6? No, I'll have 4 unknowns. Are you able to understand? So these unknowns
Yes.
which I'm talking here is all about dependent on the degrees of freedom. It is not always a 6 unknowns. It can be even 4, 3, depending on the degrees of freedom of your manipulator. Right. So coming back to like which I already gave you this issues in inverse kinematics. What are the issues in inverse kinematics? One is, and I did not come back here. One is what? Existence of solution. Then multiple solutions. Third, existence of solution, multiple solution. Then What is that?
No solution.
Yes. No, no. Existence of solution itself is a no solution. Then is a multiple solutions. Then is basically the complexity, right? Which I already told you now. It's a non-linear equations, right? Highly non-linear equation. Now think of here. This is what again a issue, right? Where you have 12 equations and 6 unknowns to the max, where you have to bring down it to 6 and 6 equations, 6 unknowns, right? Which are highly non-linear, right? So this is again an issue. Solution methods also, the choice of solution methods. Now, what are basically the solution methods which we have? So there are basically two methods to solve. Please understand there are basically two methods to solve. One is the popular closed form solution, and other we call it as a numerical solution. What do you mean by numerical solutions? It's basically an iterative solutions. You would have had uh, you would have heard about something called iterative solutions, like which is Newton-Raphson, where you do not know whether like in how many iterations you will be ending up in an optimal solution, right? So it is kind of a very complex task where you just need to go on iterating unless you get you get a optimum. So you do not have an idea like how many iterations do you really want. So these are very computationally extensive, these numerical solutions. Now I'll talk about what is a closed form solution. Closed form solution is basically an analytical or algebraic, right, or kinematic solutions. It's basically dependent on the kinematic solution. So these are faster because the number of operations which you do is very limited compared to an iterative solutions. Now, if you ask me like what is it all about, so this simply means it's a solution method based on kinematic approach where which gives the expression, right, of joint displacement in terms of the pose of your end effector. Now, if you ask me, I'm please understand, I'm going a bit deeper into this closed form solution. If you ask me, what does it really mean? For example, closed form solution simply means I have here unknown matrix. I have here a matrix which is a forward kinematics, or I say like it's a pose which my end effector need to reach, and this is a forward kinematic matrix which contains all my joint angles. Now, one way is like I can just directly, right, directly uh, inspect, saying like if there is any variable which is left apart as single. Now think of if there is a variable which is left apart as a single, what can I directly do? I can just directly relate it with the elements of its which is dependent on, right? For example, if it was 15, I could say like theta 1 is equal to 15. Is it right?
Yes, sir.
Right. And some other says like theta 1, theta 2. What can I do? When I already got theta 1, theta 1, so I can solve for this combination of theta 1, theta 2. So all these are direct inspection. One is I just directly see whether is there any joint angles which are independently available to me. Please understand the term, which is independently available to me, which I can solve directly. If not, what can I do? I need to make in such a way where I have a minimum variables here which could be solved. So I'll come back to it. Okay. So this is what is basically a closed form solution is all about. So that means at any time when you have basically 12 equations to solve for 6 variables, now you are making it available in such a way where I convert this into 6 equations so that I have 6 variables which can be directly solved. Right? It can be by direct way or whatever way that I'll come back and explain to you. Is it clear what I'm saying?
Yes, sir.
Now, if you ask me, think of, is it like always does the solution exist? When does the solution exist? Unless and until I have any of this joint angle independent. Now think of, I have a matrix which is all dependent. Like think of theta 1, theta 2, theta 3. Here theta 4, theta 5, and theta 1. All these are like this. Will I be able to solve? It is very difficult. I cannot. So there are conditions. It is not like for every 6 degrees of freedom I can apply this closed form solution. Please understand this. I am going to talk about the condition where I can apply this closed form solution. So this closed form solution can only be applied, and this is condition for only 6 degrees of freedom. For 6 degrees of freedom and higher, for less than 6 degrees of freedom, this might be applicable. This might not be applicable. Okay. For a 6 degree of freedom robot, if you want this closed form solution to be possible, so the necessary condition is like it should have 3 minimum, like means 3 joint axes intersecting. Please understand the minimum condition, right? The minimum condition for the closed form solution to be applied is the 3 joint axes should be intersecting, or when I'm saying 3, It's basically consecutive. Please understand, 3 consecutive. It cannot be like 1 then 4. No, it's consecutive. One after all the 3, right? All the 3 joint axes should be intersecting, or the other condition is either one. 3 consecutive joint axes are parallel. 3 consecutive joint axes are parallel. What does it mean? Think of the beauty here. If you look at any 6 degrees of freedom robot, typical industrial robot, what does the first 3 degrees of freedom? The first 3 degrees of freedom will be like this. And what is the other last 3 degrees of freedom? The last 3 degrees of freedom will be the wrist degrees of freedom. Does it make sense? It will be
Yes, sir.
spherical wrist mostly. And you already applied the spherical wrist kinematics. What was the spherical? How did you solve for spherical wrist kinematics? We assumed like all the 3 joint axes was intersecting. Does it make sense? You remember that when we solve for forward kinematics? I said
Yes.
roll, pitch, and yaw. These were intersecting. So when it is intersecting, can I apply this closed form solution? Yes, I can apply. Are you able to understand? Now think of that condition is met. So that means for a 6 degrees of freedom, either the wrist degrees of freedom should be intersecting or any. It is not, see, it is not mandatory that it should be the last. If it is in between also, it should ensure that at least you have 3 joints which intersect with each other. And why is it important is like, unless you have this intersecting property coming in, you will not be able to segregate. For example, a combination of theta 1, theta 2, theta 3 comes, you will not be able to segregate these joints separately so that I will find a solution for it. Are you able to understand what I'm talking about?
So can you repeat the last part?
See, what I was, see, why do you want really intersecting or a parallel is, when you have combinations of angle, for example, theta 4, theta 5, theta 6, as one of the element of the matrix, right? So if you have such things like intersecting or this, you will have a high chance like where you find independent angles which could be solved. Otherwise, if you don't have this property coming in, you will have all dependent, where you will not be able to really segregate any of these angles apart, any of the angles out of it, so that you can make a independent angle to solve. This while solving you will understand. Is it clear till here? So that means either the 3 joint axes, consecutive joint axis should be parallel, or I should have 3 joint axes which is intersecting, either one, for 6 degrees of freedom. Don't ask like for 3 degrees of freedom, how does it happen? It doesn't. 3 degrees of freedom is easy to solve. Is it clear?
Yes,
So
sir.
let me give you an example. So what are the various guidelines to obtain? See, very simple guideline which I generally follow. One is, look at the matrix carefully and see whether any of the joint variable can be directly solved. So first thing which I do is like, I find out whether any of the joint variable can be directly solved. What do you mean by directly solved? By just direct comparison. Okay, I see like if there is any joint angles which are independently available, I just solve it. If not, if this is also solved, next thing is like, is there anywhere available which is a pair of joint variable, maybe a pair of joint pair variable, which also has a joint which is already computed. Are you able to understand this word sentence which I'm using? Think of, I solved previously for theta 1, and I have another joint pair which is theta 1, theta 2. Will you be able to solve for this? Yes. Why? Because I already know theta 1. Are you able to understand?
Yes, sir.
If these two are already exhausted, you don't have any other way, you just need to find some ways to eliminate. Okay, so that I'll tell you how do we really eliminate things so that you get more independent angles. So that is how we normally apply inverse transforms. I'll tell you what is it. I apply inverse transforms. And the most important part here is the use of a tan 2 arc tangent function. A tan 2 rather than a tan, which I already told. This is very, very important. Right? So what do you mean by a tan 2? It is called, instead of like arc cosine or arc sine functions, we use an argument, 2 argument a tan 2. So this returns an accurate angle in the range minus pi. So please understand, it gives you a value which is minus pi to pi. Okay. And the advantage of this I'll explain to you. So understand, like you need to use a tan to, not you cannot use a tan. Okay, with this, let me solve one simple problem. Is it clear till here? At least some idea got?
Yes, sir.
Yeah, I'm going to solve one very simple problem. Okay, so uh, I think articulated arm, 3 degrees of freedom was already solved. Is it correct? Forward kinematics was already solved, right?
Yes, sir, you did.
Yes, sir, we did, sir.
We did. You did, no? Okay, right. Okay. Now, please understand, which I said, you will not be using. Please understand, you will not be using any cosine or sine. You'll be only using a tan 2. Okay. So with this understanding, what we will do, I'll tell you the steps which we will use to solve inverse kinematics for articulated arm. So, what is given to you in the inverse kinematics? What is given to you? First thing, you should understand what is given to you. What is given to you?
Degrees of freedom.
Yes. So what does it really mean? What is given to you? End effective force is given to you, right?
Yes, sir.
Is it not? Think of end effective force is given to you. Does it make sense? So how do
Yes,
you
sir.
really describe the end effective force mathematically? Of course, that can be described by a 4 cross 4 matrix. So what is given to you? Some constant matrix is given to you, which carries maybe like R11, R12. These are just values. R13, and I'll say here R14, R21, R22, R23, R24, R31, R32, 0, 0, 0, and 1. So this is given to you, right? So that means you know where my end effector should reach. Clear?
Yes, sir.
Right. Now what is the second thing which you can do? Now I know this is my end effector force. So this, can I equate this with the forward kinematic model? Yes. Why? Because this is what I really want, right? This is my final transformation which I really want. Is it correct? This is my what I want, T0, T3 with respect to 0. This is what I really want. Is it right? So
Yes.
do I have the solution for forward kinematics of articulated arm? Yes. What is that? I know that it is C1, C2, 3. I'm writing it directly, okay?
Sir, sorry to interrupt.
Sorry?
Sir,
Hello?
sir, can you hear me?
Hello? Hello?
Sir, it's just S1 on the top.
Ah, this is sine theta 1.
Sir, is it positive?
Is this positive for the previous one which you derived?
Yes, sir, it is.
Oh, I think the solution which I have is, or maybe like you would have taken the z axis differently. Where you have taken the z axis, inside or outside? I don't know. That you have to cross check. Okay, like positive or
Okay.
negative, whatever it be, no issue. Only sign is changing, right? All other magnitudes are the same, right?
Yeah, sir, S
Yeah,
same.
yeah, that is okay, no issue. right? Now what will you do? Now think of, is this correct? I just related it what I really wanted to reach. So I have this. So this, I need to find a solution for the joint angles, right? I need to find, for reaching this pose, right, which my user have defined, what should be my joint angles. First thing which should, and so we are finding the closed form solution. The first thing which you should do is what? Check whether by direct inspection am I able to do that or not. By direct inspection, did you find any independent angles? Did you find any independent angles? Huh? I have my S1, C1 here, right? And if you look at these two also, please understand. See, it is always best practice. Please understand. Please listen here. It is always a good practice to check the last column, because you have a higher probability where the last column always ends up in some independent parameters. If you look at this, if I divide my sine and cos, now think of, see, please understand, I'll be only taking tan function, right, which I already told you, a tan 2. Now when I'm saying a tan 2, please understand, a tan 2 uses two arguments, x and y. And what does the tan mean? Tan is sine by cos, right? So it should have an argument of sine, it should have an argument of cos. It simply means x is typically my sine and y is typically my cosine. Please understand. So typically if I use these two, you can use these two also, but what I'm doing, I'm using these two. So I'm going to divide these two. Okay, so what does it mean if I'm going to divide that? I have my S1 L3 C23 plus L2 C2 divided by C1 L3 C23 plus L2 C2 equal to, what can I really equate with? R14, sorry, R14 is it? No, R24 divided by R14. Does it make sense?
Yes, sir.
Right. So what happens? This gets cancelled. So what will I end up in? I'll end up in sine 1 by cos 1, which is R24 by R14. Does it make sense?
Yes, sir.
So now think of, easy. Now what I need to do? I need to solve for tan inverse, right? This is tan, right? Tan theta 1. Is it right? Theta 1 is tan inverse of this. Is it correct?
Yes,
Yes,
sir.
sir.
But I told you we will not be using tan. What I'll be using? A tan 2. I'll tell you what is the difference between, it's again a same tan inverse, but I'll tell you what is a specific about A tan 2. Now how will I solve for A tan 2? What is the sine arguments? R24. What is my cosine argument? R14. So this is what is going to give me theta 1. Are you able to understand?
Yes, sir.
Right? So it's simply like, think of what I got here is tan theta 1 is equal to R24 by R14. If I want theta 1, I'll be taking tan inverse of R24 by R14, right? So instead of by, I'll take two arguments. One is R24, other is R14. These are two arguments. And instead of tan inverse, I'll be using A tan 2. A tan is basically tan inverse, right? A tan is tan inverse, but I'll be using A tan 2 function, which I'll tell you what is important. So I got theta 1. Correct? Any doubt in this?
No, sir.
So is there
Yes,
any other
sir.
way to solve it? Yes. You can even take this, right? Think of, can't you take this also? Yes. What will that give you? I'll get sine 1 equal to minus R13, right? If I want to divide by cos 1, I'll have my sine 1 by cos 1 is how much? R23, correct?
Yes, sir.
So what will be your A tan 2? A tan 2 will be minus R13 comma R23, correct? So don't leave this minus. It's very important. Is it clear?
Yes, sir.
Right.
Yes, sir.
So you got this independent. So this is how the first closed form solution's first step works is, you just see whether by direct inspection are you able to find some independent angles or not. Right? So once this is done, so you check out, is there any other independent angles which you could really solve for? Any other independent angle which you could solve for?
Sir, minus C1 S2
Theta
3.
1 is already solved. You need not again solve for theta 1, right? Somehow you solve for theta 1. So what is the other angles which you need to solve for?
C23.
Theta 2 and theta 3 you need to solve for. So do you have anywhere which has uh, which is independent where you could solve by direct inspection?
S1 C23.
Which one? See, if you look at all of the
First,
combinations, these are again a combination of theta 2 and theta 3, right? Think of it. I have here C23, which is theta 2 plus theta 3. Here also, everywhere. I don't have anywhere where I cannot segregate this alone apart, right? Make sense?
yes, sir.
Are you able to understand? See, either it's a combination of theta 2, theta 3, or you have theta 2. There is no combination where 1 and 2 comes, right? So can you directly solve? Can you directly solve? No. So the other two unknowns cannot be obtained directly. Is it correct? So I'll put here a statement. Now, I understand my theta 2 and theta 3 cannot be solved. So important point here is cannot be solved directly. Correct? So what I need to do? So that means I need to find some solution using some inverse transform approach. Okay, that's what I said. I need to eliminate, right? I should ensure that on, see what was the problem here? My LHS, right? This is my LHS, right? Is it right?
Yes, sir.
So this is my LHS where I had a combination of all theta 1, theta 2, theta 3. So if I'm able to eliminate this theta 3, please understand, if I'm eliminate this theta 3 out of this, I'll have only a function of theta 1 and theta 2. Is it clear?
Yes, sir.
Then I'll be able to check whether things work out or not. Okay. So that is what my point here. Please understand. That is what my point here is. So that is what is called as inverse transform. So you should be able to understand all these inverse transform.
So can't we eliminate theta 2?
Anything, anything. Theta 2 or theta 3, whichever it be.
Okay, sir.
Okay. Now how do I do that? So please understand. The only thing which I should understand here is the matrix which I got here is a combination of three matrices, and this is my final matrix T. Is it correct? So I'll put it in this way where I have my T1 with respect to 0 into, is it correct? Which is equal to T. What is T? T is the transformation which my user has given me. Correct?
Yes, sir.
So in this, what do you think will be the variable in T1 with respect to 0? I'll have only the joint variable theta 1, right? Because you use the first row of the DH matrix, DH table, right? So how did you get this? This you obtain by the second row of the DH matrix, DH table, which is only theta 2. So that means this transformation will only have theta 2 as a variable, and this transformation will only have theta 3 as a variable. Is it correct?
Yes, sir.
Correct?
Yes, sir.
So what will you do now? The point here is like, if I want only, please understand, if I want only theta 1 and theta 2 to exist here, the only way is like I just put this, right, theta 3. So I multiply and inverse with this T. Now, as one of your friend asked, why can't I eliminate theta 2? Please understand, whenever you do that, ensure that this LHS is always equal to RHS. What does it mean? Now think of the user which is given, is it not T3 with respect to 0? Is it not? Rather than writing T, it is basically T3 with respect to 0, right? I want to know where is my derivative with respect to base. Is it correct?
Yes, sir.
So when I'm applying an inverse, please understand what am I alluding? I am applying, if I want to apply inverse, what does it mean? I will just want to take an inverse of this and multiply on both sides. When I do that, what happens? This gets cancelled, so I'll end up in t1 with respect to 0, and I'll end up in t2 with respect to 1, which is equal to, if I multiply here, please understand, if I'm going to multiply here with that, so I'll have t3 with respect to 0 into multiplied by t3 with respect to 2, the whole inverse. In the other way, how can I write? I can write this as t3 with respect to 0. I'll have here t2 3. Correct? Is it correct?
Yes, sir.
Now, is it violating? Think of. Why? Because when I cancel this one, I'll end up in t2 with respect to 0. That is what my LHS is giving. Now, think of in this RHS. Is it the same? t2 with respect to 0? Correct, right? Correct, right?
Yes, sir.
So, there is no harm in multiplying the inverse of t2 with respect to 3. So, this holds good. Now, as your friend asked, why can't I eliminate this theta 2? Let us see that. Okay. So, for eliminating theta 2, what I need to do? I need to multiply the inverse of what? I need to multiply the inverse of what? Is after all this, you should be able to answer that, right? If I want to, now what I was doing here, I eliminated my theta 3 from LHS, right? I have only 1 and 2 here. If I really want to have theta 2 eliminated, that means I should have only 1 and 3. So with what I should do the inverse? Multiply the inverse.
T
Huh?
1 and 2.
Right. So what I should do? I should take inverse of t2 with respect to 1, right?
Yes, sir.
So you just see that. So what I'll do? I'll take inverse. So this gets cancelled. So I'll end up in t1 with respect to 0. I'll end up in t2 with respect to 3. So when I do that, I'll have here t3 with respect to 0. I'll have here t, if I take inverse, this 2 goes up, this comes here. But does it hold?
No, sir.
Is it? No, it is not, right? You think of it doesn't give you any transformation back here. Now you think of this is not at all same. Are you able to understand?
Yes, sir.
So please, this is a very careful, be very careful when you do this inverse transform approach in the closed form solution. Ensure that you always meet this LHS equal to RHS. So you cannot just eliminate any angle just multiplying the inverse. This is a very important concept, and this is what students make lot of mistake. Lot of mistake they do, just multiply without understanding whether this really is applicable, mathematically applicable or not.
So we
Yeah.
have to do this before we start eliminating.
No, this you should understand how to eliminate. See, is it possible to eliminate theta 2 or is it possible to eliminate theta 3? By this rule, you should be able to understand. If you understand this, what you do, you just multiply the t3, whatever is here, you just multiply it. Just hold on, okay? I'm getting an important call. Just wait 1 minute. Right, able to hear me?
Yes,
Yes,
sir.
sir.
Yeah, right. Okay, so what I was talking here, yeah. So this is what is important. So you should understand like what to be eliminated, right? And whether it really matches both LHS and RHS. Very important. Now, point here is like how do you take inverse of this homogeneous transformation? You know that? See, if you start doing with the normal, it will take a lot of time, right? You cannot. How will you take the inverse? You know the procedure. I'll stop from till there because I have another meet, so I'll not extend. The class is till 12:25, right? Okay, 5 more minutes are there. I have a meet at 12:30, so I'll wind up with this most. So did you understand like how do I do the next step? The first was a direct approach. Next, you understood this,
Yes, sir.
right?
Yes, sir.
Right. So after this, so one thing you should understand here is like how to take inverse. You know how to take inverse? So please note here, inverse of homogeneous transformation. I'll take a very shortcut method. I'll use a very shortcut method, and this you use this for finding it. Okay. So I'll write it generally nx ox ax ny oy ay nz oz az 0 0 0 1. I have here px py and pz. Okay, if this is the final matrix, right, and you want to take inverse of this, that means I want to take inverse. So what you first do is you take first the transpose of this 3 cross 3. Okay, are you able to understand? Are you able to understand? You take the transpose here, and if it is R, please understand, if it is denoted by R, you take the transpose R, transpose of that R, right? And you fill that 0 0 0 1, and the last element becomes minus NP. Here it becomes minus OP. This becomes minus AP. I'll tell you what is this NP. NP stands for NX PX plus NY PY plus NZ PZ, where OP stands for OXPX plus OYPY plus OZ, where AP stands for AXPX plus AYEY plus AZPZ. You will understand. So what does this NP mean? You just multiply NXPX, NY, this NY into PY, NZ into PZ, and put a minus and put that value here. Okay. Now, what is OP? OX into PX, OY into PY, OZ into PZ, and just put that value there. Okay. So this is what you find. This is how you find the inverse of this transformation matrix. Able to understand? Very easy way.
Yes, sir.
Okay, so we'll stop here for today. Okay, so please understand. So what I said, closed form solution, I told you the methods. One is a direct, second is try to eliminate one of the angle by taking an inverse transform. Then we understood like how did we take the inverse. Okay, now tomorrow I'll tell you, or the next week which is coming, which next day order which is coming, I'll tell you like how do we really have this inverse multiplied and get a solution for theta 2 and theta 3. Okay, this is what we are left behind. Clear?
Yes, sir.
Any doubt? Any doubt?
No, sir.
Anybody? Yeah, I don't know whether everyone is able to understand or not. I could hear only few